This is SpaceTime, Series 22, Episode 23. Coming up on SpaceTime, new studies show the Milky Way is warped and twisted, the asteroid Bennu spinning faster over time, and a second giant impact crater found in Greenland. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
The first accurate three-dimensional map of our Milky Way galaxy shows that it's warped and twisted. A report in the journal Nature Astronomy claims this warp spiral pattern is being caused by torque off the spinning of the Milky Way's massive inner disk of stars. The new observations are based on the positions of 1,339 Cepheid variable stars, which were used to map the Milky Way's real shape. They found the Milky Way's disk of stars becomes increasingly warped and twisted the further away the stars are from the galactic centre. One of the study's authors, Professor Richard de Grace from Macquarie University, says people usually think of spiral galaxies as being flat disks. The problem is, trying to determine the real shape of our galaxy is a bit like standing in the middle of the woods and trying to determine the exact size and shape of the whole forest. It's also notoriously difficult to determine distances from the Sun to some parts of the Milky Way's outer gaseous disk without having a clear idea of what the disk actually looks like. However, over the past 50 years or so, there have been some tantalizing hints that the hydrogen clouds of the Milky Way could be warped. From a great distance, our spiral galaxy would look like a thin disk of stars that orbits roughly once every 250 million years around the central region, where hundreds of billions of stars provide all the gravitational glue needed to hold the galaxy together, apart from dark matter, that is. But it now seems this pull of gravity is far weaker in the galaxy's far outer disk. There, the hydrogen atoms making up most of the galaxy's gas disk are no longer confined to a thin plane. Instead, they give the disk an S-like or warped appearance, caused by the huge amount of torque coming from the spinning of the Milky Way's massive inner disk of stars. The key to developing this new three-dimensional map was a recently published catalogue of young variable stars known as classical Cepheids located in the warped Milky Way disk. Data on these stars was provided by NASA's WISE, Wide Field Infrared Survey Explorer spacecraft. The authors were able to use 1,339 of these Cepheid variables to help them develop their map, and this allowed them to determine the twisted appearance of the galaxy's far outer regions. Classical Cepheids are some 4 to 20 times as massive as the Sun and up to 100,000 times as bright. Cepheid variables pulsate, that is, expand and contract, at set rates based on their intrinsic luminosity, and so they can be used as standard candles to measure cosmic distances. Because astronomers know how intrinsically luminous a Cepheid variable star is, because of its pulsation rate, they can determine how far away it must be. It's exactly the same as looking at a row of streetlights down the road. You know they've all got the same brightness, but the ones further down the road will appear dimmer than the ones nearer to you. This allows very accurate distances to be determined for these stars, with an error of only 3 to 5%. The new research provides a crucial updated map for studies of the Milky Way stellar motions and the origins of the Milky Way's disk. De Grace reminds us that most of the matter in the Milky Way is dark matter, which is an intrinsic part of our universe. But de Grace also points out that not only do scientists not have any idea what dark matter is, they're not even sure exactly where it is. The new research showing the real shape of the Milky Way could help scientists better determine how dark matter is distributed around the Milky Way galaxy. The authors were also surprised to find that their three-dimensional collection of 1,339 Cepheid variable stars and the Milky Way's gas disk showed the stars tended to follow each other closely. De Grace says that discovery offers new insights into the formation of the Milky Way. He says perhaps more importantly, he found that in the Milky Way's outer regions, the S-like stellar disk is warped in a progressively more twisted spiral pattern. Astronomers have observed dozens of other galaxies which have shown similar patterns. De Grace says that means the Milky Way's twists are rare, but not unique.
What we found is that towards the outer regions of our Milky Way galaxy, our galaxy starts to deviate from a flat pancake shape. Now, that was known for a long time in its distribution of gas, and by gas I mean hydrogen atoms, of which we knew for the last 5 decades or so that in the outer regions the hydrogen gas would deviate from the plane, become higher on one end and lower on the other end. Now, our study, among the results that we found for the first time that the young stars in the Milky Way, traced by so-called Cepheid variable stars, which are quite massive and therefore quite young, follow that same kind of warped distribution where there is a clear deviation from this flat pancake shape. But that's not everything. Also, what we found is that the main direction of this warp is not a straight line, but it starts to more or less trace a spiral structure as we go further and further out, in the sense that this warp becomes twisted at greater and greater radii.
Is this anything to do at all with the talk on stars within the galaxy caused by the galaxy's rotation?
Yeah, so our interpretation of this result is that the massive disk of stars making up most of the Milky Way is rotating around the center of the galaxy every 250 to 300 million years, and it's dragging behind it the outer layers, which are less strongly gravitationally bound to the Milky Way because they're much further out. And so that rotation in the warped outer disk is slightly lagged behind.
Is there any connection between this warped structure and the thick and thin disks of the Milky Way? Is there a correlation there?
That's a good question, but we haven't actually looked at that. Now, having said that, the bulk of the stars in our Milky Way are distributed in the thin disk. That's really the vast majority of stars. The thick disk is puffed up somewhat, and it tends to extend to greater radii, but at much lower numbers of stars than the thin disk. The warp's distribution of stars would deviate from this thin disk into the realm of the thick disk. So there might be some dynamical interaction, but I would say that the warp itself originates from the thin disk and is probably most closely associated with the thin disk. I don't think that this has to do with the spiral structure of the Milky Way as such, because it's quite well known by now that the longevity of these spiral arms is due to something called density waves, where stars move around the center of the Milky Way and they get attracted by the higher density of material in the spiral arm. So they move faster towards the spiral arm, spend more time there because of gravity, and they move out slowly. And in between the spiral arms, they don't spend much time. That's the density wave theory. I think that is that's a completely different dynamical process. In this particular case, we believe that we really see this gravitational torquing, the dragging behind of material by the inner massive disk.
What do you need to do next for your research?
Well, there's a couple of things that we can do. First of all, we looked at about 1,300 or so of these Cepheid variables. That's a sizable sample, but it can always be improved. One of the problems with our sample is that all of these stars were located on the near side of the Milky Way center, so on our side of the center. It would be great if we could get similar quality data on the other side of the Milky Way center, so that we could see whether or not the features that we have found are symmetrical. And that is more than just an academic exercise. The idea here is that if the warped distribution of the Cepheids and the twisting is symmetrical on either side of the Milky Way center, then we truly have a process here that works across the galaxy. Colleagues have suggested that what we've seen might have been caused by the infall of a dwarf galaxy towards the outer regions of our Milky Way. And if that's the case, you would only expect it on one side. So that's one thing that we would like to explore. Another thing, of course, is that you probably know very well that the European Space Agency is currently operating its Gaia satellite, which is meant to determine positions and distances to about 1 billion stars in our Milky Way galaxy. The first data release has come out. The second release is due soon, but the full data set will not be released for another 3 to 5 years. By that time, accurate 3D map of our Milky Way galaxy, and hopefully our result will serve as a benchmark to hold those Gaia results against. And then finally, the other the quite exciting prospect here is that by constraining the distribution of stars in our Milky Way more carefully than before, we may have a fighting chance of determining where all the dark matter in our Milky Way is located. And that's still a big open question.
That's Professor Richard de Grace from Macquarie University in Sydney. And this is Space Time. I'm Stuart Gary. Astronomers have found that the asteroid Bennu is gradually spinning faster over time. Observations show that instead of gradually slowing down over time, Bennu's rotation rate is increasing by about a second every century. The findings, reported in the journal Geophysical Research Letters, will help astronomers better understand the evolution of asteroids and the forces influencing them. This will allow scientists to provide a more comprehensive understanding of the dangers asteroids pose to life on Earth, as well as their potential as targets for mining. NASA's Origin, Spectral Interpretation, Resources Identification, Security Regolith Explorer, or OSIRIS-REx spacecraft arrived at Bennu in late 2018 on a multi-year sample return mission. They have kilometre-wide asteroids located 110 million kilometres away from Earth. And OSIRIS-REx is slated to bring a sample of Bennu back to Earth in 2023. As it moves through space at some 101,000 kilometres per hour, Bennu also spins, completing a full rotation every 4.3 hours. The asteroid's increase in rotation rate by around a second every 100 years might not seem like much, but over a long period of time that can translate into dramatic changes in the space rock. The study's lead author, Mike Nolan from the University of Arizona in Tucson, says as the asteroid spins faster and faster over millions of years, it could lose pieces of itself, literally flinging them off. In fact, it could blow itself apart completely. In order to understand Bennu's rotation, scientists studied the asteroid data taken from Earth in 1999 and 2005, along with data taken by the Earth-orbiting space telescope Hubble in 2012. It was when they looked at the Hubble data, they noticed the rotational speed of the asteroid in 2012 no longer matched the predictions based on the earlier data. Nolan says the idea that the rotation of asteroids could speed up over time was first predicted around the year 2000. However, to date, this acceleration has only ever been detected on just a handful of asteroids. The change in Bennu's rotation could be due to a change in its shape. In other words, bits have been flung off. Just like spinning ice skaters speed up as they pull their arms in, an asteroid can speed up as it loses material. However, Nolan and his co-authors suggest the reason for the increase in Bennu's rotation is far more likely to be due to a phenomenon known as the Yorp effect. It works like this. Sunlight hitting the asteroid is reflected back into space. The change in the direction of the light coming in and going out pushes on the asteroid and can cause it to spin either faster or slower depending on the shape and rotation. OSIRIS-REx will determine Bennu's rotation rate independently this year, and that will help scientists nail down the reason for the increase in rotation. 1955 Bennu is a carbonaceous asteroid in the Apollo group discovered by the LINA project back on September 11, 1999. It's a potentially hazardous near-Earth asteroid. It has the second highest rating on the Palermo Technical Impact Hazard Scale, with a 1 in 2,700 chance of impacting the Earth sometime between 2175 and 2199. The asteroid's named Bennu after an ancient Egyptian mythical bird associated with the sun, creation and rebirth. I'm Stuart Gary. This is SpaceTime. Scientists have discovered what could be a second possible impact crater buried under more than 1.5 kilometres of ice in northwestern Greenland. The 37-kilometre-wide crater, reported in the journal Geophysical Research Letters, follows last November's discovery of a 30-kilometre-wide crater beneath the Hiawatha Glacier, the first meteorite impact crater ever discovered under Earth's ice sheets. Though the newly found impact sites in northwestern Greenland are only 180 kilometres apart, at present they do not appear to have formed at the same time, and so are unlikely to have been caused by the same event. Now, if the second crater is ultimately confirmed as the result of a meteorite impact, it'll be the 22nd largest impact crater ever found on Earth. One of the study's authors, Joe McGregor, a glaciologist with NASA's Goddard Space Flight Center in Greenbelt, Maryland, who participated in both findings, says despite having surveyed the Earth in many different ways, from land, air and space, it's exciting that discoveries like these are still possible. Before the discovery of the Hiawatha impact crater, scientists generally assumed that most evidence for past impacts in places like Greenland and Antarctica would have been wiped away by the unrelenting erosion of the overlying ice. But following the discovery of that first crater, McGregor checked topographic maps of the rock beneath Greenland's ice looking for signs of other craters. Using imagery of the ice surface taken by the moderate-resolution imaging spectroradiometer instrument aboard NASA's Terra and Aqua satellites, he soon noticed a circular pattern some 180 kilometres to the southeast of the Hiawatha Glacier. The same circular pattern also showed up in Arctic DEM, a high-resolution digital elevation model of the entire Arctic derived from commercial satellite imagery. To confirm his suspicions about the possible presence of a second impact crater, McGregor studied the raw radar images that are used to map the topography of the bedrock beneath the ice, including those collected by NASA's Operation Icebridge. What he saw under the ice were several distinctive features usually associated with a complex impact crater. There was a flat, bowl-shaped depression in the bedrock, which was surrounded by an elevated rim, and centrally located peaks, which form when the crater floor equilibrates post-impact. McGregor says the only other circular structure which could even approach the size would be a collapsed volcanic caldera. But the areas of known volcanic activity in Greenland are several hundred kilometres away, and a volcano would have a clear positive magnetic anomaly, while measurements from Operation Icebridge revealed a negative anomaly over the area, something normally characteristic of impact craters. Although the two newly found impact craters in northwest Greenland are only 180 kilometres apart, they don't appear to have been formed at the same time. Using radar data and ice cores that had been collected nearby, McGregor and colleagues determined the ice in the area was at least 79,000 years old. You see, the layers of ice were smooth, suggesting the ice hadn't been strongly disturbed during that time. This meant the impact either happened more than 79,000 years ago, or if it took place more recently, any impact-disturbed ice had long ago flowed out of the area and been replaced by ice from farther inland. The researchers then looked at rates of erosion. They calculated that a crater of that size would have initially been more than a kilometre deep between its rim and floor, which is an order of magnitude greater than its present depth. Taking into account a range of plausible erosion rates, they worked out it would have taken somewhere between roughly 100,000 and 100 million years for the ice to erode the crater to its current shape. The faster the erosion rate, and the younger the crater would have been within the plausible range, and vice versa. McGregor says the ice layers above the second crater is unambiguously older than those above Hiawatha, and the second crater is about twice as eroded. If the two did form at the same time, then likely thicker ice above the second crater would have equilibrated above the crater much faster than for Hiawatha. I'm Stuart Gary. This is SpaceTime. A Russian Soyuz rocket has blasted into orbit carrying the Expedition 59 crew bound for the International Space Station. The launch from the Baikonur Cosmodrome in the Central Asian Republic of Kazakhstan provided the crew with a 6-hour fast rendezvous flight to the orbiting outpost, which was flying about 400 kilometers above southern Russia and about 1,770 kilometers ahead of the Soyuz as it left the launch pad.
Soyuz vehicle now 1 minute from launch. The first umbilical tower beginning to separate right now. Vehicle on internal power. Now just under 30 seconds from launch.
Onboard power. Launch command issued for ignition.
Second umbilical tower separated. Booster ignition.
Engine turbo pumps at flight speed. Engines at maximum thrust. Lift off.
And lift off. We have liftoff of Nick Hague, Christina Cook, and Alexei Ovchinin, now on their way to the International Space Station. Good first stage performance so far, the Soyuz delivering 930,000 pounds of thrust from its 4 boosters and single engine. The first stage of the Soyuz measures 68 feet in length, 24 feet in diameter, burning liquid fuel for the first 2 minutes, 6 seconds of the flight. 1 minute into the flight, everything looking good so far. The vehicle itself is now traveling at more than 1,000 miles per hour. This first stage with the 4 strap-on boosters will continue to burn until 1 minute 58 seconds. Good reports to the crew. About 10 more seconds of this first stage. The escape tower has been jettisoned. The 4 booster separations have been confirmed. That core stage continuing on as the second stage. The launch shroud will be jettisoned at 2 minutes 37 seconds into the flight.
The crew is feeling great.
Soyuz vehicle traveling well over 3,000 miles per hour.
The launch vehicle parameters are nominal. Copy all. Everything is nominal on board.
Good core stage performance. The launch shroud has been jettisoned. The rocket is now at 48 miles high. Good reports so far. This core stage will continue to burn until the 4 minute 43 second mark. The Soyuz vehicle traveling about 5,000 miles per hour.
200 seconds. Second stage.
Soyuz core stage is performing as expected. That core stage, 56 feet in length, 13.5 feet in diameter, with a single engine and 4 fuel chambers, providing between 178,000 and 222,000 pounds of thrust for its 3 minute 28 second burn. The Soyuz uses what's called a hot staging technique. Third stage will ignite while the second is still burning. And that lattice structure at the center of the vehicle of
250 yaw pitch roll are nominal.
Good separation of that second stage.
Second stage separation is confirmed. This is Burlock 1. I confirm that. Everything is nominal on board. The crew is feeling great. 310 seconds. The spacecraft is stable.
Good third stage performance. Everything looking good. This booster will continue to burn until the 8-minute 45-second mark. Just over a 4-minute burn.
330 seconds.
At this time, the Soyuz vehicle well over 100 miles above the Earth.
This is Burlock 1. Copy all. Everything is nominal on board. The crew is feeling well.
The single engine of the Soyuz's third stage providing 67,000 pounds of thrust. Everything looking good so far for this last stage before the Soyuz itself is inserted into orbit 8 minutes 45 seconds after launch.
Third stage thrusters are operating nominally. We are standing by for third stage separation at 22:56. Copy all.
At this time, the Soyuz vehicle traveling well over 13,500 miles per hour. Once the third stage delivers the Soyuz to orbit and the module is separated, a series of pre-programmed commands will be executed to prepare the Soyuz for orbital operations. These stored commands, called time-tagged commands, allow many of the Soyuz's systems to be automatically activated by onboard computers at precise times stored in those computers.
Everything is nominal on board. The crew is feeling great. This is Burlock 1.
We have good third stage separation.
Third stage separation is confirmed.
Stage cutoff and separation occurring.
Burlock's congratulations on the orbit insertion. Mission Control Moscow is standing by, and they're here.
The crew's antenna has deployed at this time.
Burlock, Moscow, how copy? Moscow, this is Burlock 1. Have you loud and clear?
At this time, all the antennas and solar arrays are deployed.
Third stage separation was nominal. Everything is nominal on board, and we are feeling great.
Soyuz now in orbit, solar arrays deployed, and the Soyuz crew on their way to the International Space Station, docking just 6 hours from now. The Soyuz itself orbiting at an altitude of about 143 miles by 118 miles.
Moscow, this is Burlock 2.
The orbit will be raised systematically over the next 6 hours. The control of the spacecraft from here will be overseen from a Russian Mission Control Center outside of Moscow.
Copy all.
3-person crew aboard the Soyuz MS-12 capsule included NASA astronauts Nick Hague and Christina Koch, together with Roscosmos cosmonaut Alexei Ovchinin. Regular SpaceTime listeners will recall that Hague and Ovchinin were the crew aboard last October's ill-fated Soyuz MS-10 launch, which was forced to undertake an emergency ascent aboard after their Soyuz rocket exploded in mid-flight. The blast was caused by the failure of one of the Soyuz FG launch vehicle's 4 strap-on liquid fuel boosters separating cleanly when jettisoned a minute and 58 seconds after launch. Instead of flinging out and forming a Korolov cross with the other 3 strap-on boosters well away from the spacecraft, it remained partially attached, crashing back into the Soyuz core stage and triggering a catastrophic failure which destroyed the launch vehicle. Luckily, the Soyuz MS-10 capsule was safely catapulted away from the main blast, eventually undertaking a high-G ballistic landing further downrange. Hague and Ovchinin escaped with just a few minor bumps and bruises. The Expedition 59 crew will spend the next 6.5 months aboard the orbiting outpost. And time now to take a brief look at some of the other stories making news in science this week with the Science Report. A 15-year international study has found that modern coal-fired power stations produce more ultrafine dust particles than road traffic and can even modify and redistribute rainfall patterns. The findings, reported in the Bulletin of the American Meteorological Society, indicates filtration systems in modern coal-fired power stations are the biggest sources of ultrafine particles and can have considerable impacts on climate in several ways. In urban areas, road traffic has long been considered the main source of small particle emissions, which have the potential to adversely affect health and environment. However, long-term measurements by Flinders University has revealed that modern coal-fired power stations emit more ultrafine dust particles than urban road traffic. These particles not only harm human health, they can also affect rainfall distribution on local to regional scales by increasing the condensation nuclei count. In other words, they work like cloud seeding. Scientists also found that ultrafine dust particles can be transported in layers with high concentrations for hundreds of kilometres, causing dramatic spikes in short-term particle concentrations far away from their source. The researchers also found that increases in ultrafine dust particle concentrations match the commissioning of modern coal-fired power stations. A new study has found that air pollution is now causing an estimated 8.8 million extra deaths globally every year. The new findings, reported in the European Heart Journal, eclipses earlier studies which estimated that air pollution was causing 4.5 million deaths annually. Scientists reached their conclusions after developing a new method of modelling the effects of sources of outdoor air pollution on death rates, finding it could have caused an extra 790,000 deaths across Europe in 2015 and 659,000 deaths in the 28 member states of the European Union. Of these deaths, between 40 and 80% were due to cardiovascular diseases such as heart attack and stroke. The findings mean air pollution now causes more deaths every year than tobacco smoking. A new study has found that daughters of mothers who smoke during pregnancy have a 50% greater chance of growing up short and developing obesity as adults. The findings, published in the journal Scientific Reports, show chemicals from cigarettes travel through the mother's bloodstream to the baby and may turn genes involved in controlling growth either on or off. However, the study, based on a cohort of 30,000 Swedish women born between 1973 and 1988, only looked at daughters, so no figures for male children were available. Iran has begun testing dozens of heavily armed drones in the skies above the highly strategic Strait of Hormuz. The semi-official Iranian ISNA news agency says the tests are part of a major military exercise by the Islamic Republic. It claims Tehran is showing the world it now has the region's biggest offensive drone fleet. The Strait of Hormuz is a strategically important, narrow 33-kilometre wide strip of water linking the Persian Gulf with the Arabian Sea. It's one of the world's key maritime choke points, through which massive tankers and cargo ships carrying over 90% of the world's trade by weight converge. Paleontologists have discovered fossils from a new species of ornithopod dinosaur dating back more than 125 million years to the early Cretaceous epoch. The new dinosaur, reported in the Journal of Paleontology, has been named Gallionosaurus storisi. It once roamed across a vast Rift Valley floodplain between Australia and Antarctica in what is now the Wonthaggi Formation on Victoria's Gippsland Otway coast. Ornithropods are a major group of herbivorous bird-hipped dinosaurs. 5 fossilised upper jaws of the ancient dinosaur were found at the Flat Rocks dig site, together with the partial skeleton of a close relative called Dolichocursa picaringi, buried in volcanic sediments on a river valley floor. Paleontologists say Gallionosaurus is about 12 million years older than Dolichocursa. A new study says civilian doctors will need to brush up on their knowledge of space medicine as humans face the dawn of space tourism. More than 560 people have flown to space, and most of those were professional astronauts in top physical condition. A report in the New England Journal of Medicine claims there's only a very limited level of knowledge on how people in average physical health, or even those in poor condition with a host of pre-existing medical conditions, will deal with spaceflight, even for short periods. So, on top of dealing with the anxiety, nausea and pressure-related illnesses usually experienced by healthy astronauts, doctors will now need to plan ahead for a boom in space patients. Real Clever Science has published its top 10 biggest junk science stories of 2018, and there are some real doozies there, from support for the hocus-pocus of astrology and acupuncture to rattlesnake pills and the so-called magical benefits of drinking what they're calling raw water. With his sift through the trash heap of fake science, we're joined by Tim Mendham from Australian Skeptics.
There's always a few junk stories. It's quite sad, actually. The biggest ones might be, according to a list that's put out by an organisation called Real Clear Science. They've had a big list of the top 10, which is actually number 11, as they tend to do. Dr. Oz was a big one, because Dr. Oz, the famous TV doctor who is all full of all sorts of strange automated things, is now endorsing astrology.
Oh dear.
Sad, I know. Some of the, I won't go through all 11 of the top 10, but I mean, smart meters causing sort of cancer dangers, that sort of stuff. Raw water, which is basically untreated, etc., so it's all full of nasty things. The thing about pseudoscience journals that are out there, and they'll publish anything, and it sort of looks like it's a peer-reviewed journal, that's something very much of an issue in the scientific community. So any old article can be published, and you say it's in a magazine because you just pay them to publish it. There's a big thing in California. Now, everything's getting big in California, but for a while there, coffee as a carcinogen. Now, I think strictly speaking, everything is a carcinogen to a certain extent.
Well, whenever I buy potato chips, I always say to my friends, acrylamide. They want some?
Yeah, no. Everything. If you have it too much or if you have it in the wrong way, it was a bird-like toast. But I mean, this is now sort of being in California, they have to have a warning label that coffee is a carcinogen. Yes. B, acupuncture. The World Health Organization endorsing traditional Chinese medicine. That's number 2 on their list, in fact. And they saw that as a major issue because, strictly speaking, TCM, traditional Chinese medicine, doesn't have a lot of evidence going for it. There's a lot of anecdotal, obviously a lot of historical claims for it. It goes back a long, long way, not necessarily as long a way as people think. But anyway, I mean, there's a lot of rubbish out there in TCM.
A lot of it goes back to Chairman Mao, doesn't it?
Well, Chairman Mao sort of promoted it. Yeah. Mainly because they couldn't afford Western medicine. He could. When he was sick, he had Western medicine. But I mean, a lot of people out there in the boondocks of China couldn't afford Western medicine, so he recommended this traditional Chinese medicine. So it gave it a boost.
We are all equal, some a little bit more equal than others.
The number one issue that they say is measles resurgence and the anti-vaccination movement against measles, and that's the number one issue that this organisation sees as the big problem with junk science.
That's Tim Mendham from Australian Skeptics. And just running through that Real Clear Science list of shame for 2018, in 11th place there's Dr. Oz endorsing astrology. Then the rattlesnake pill fake cancer cure, claims linking wireless smart meters to headaches, ringing ears and brain fog. The absurd health fad of raw water, non-peer-reviewed so-called science journals which publish anything for money, the Californian jury that found glyphosate caused a case of lymphoma despite it being less toxic than table salt. Another Californian classic is coffee is classified as a carcinogen. Something else which is probably big time in California, using live bees for acupuncture. And the top 3, climate change denial, the World Health Organization trying to endorse traditional Chinese medicine, and in number 1 spot, the global resurgence of measles, much of it due to the work of anti-vaxxers. You're listening to Space Time. I'm Stuart Gary, and that's the show for now. You can subscribe and download Space Time as a free twice-weekly podcast through Apple Podcast iTunes, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, from spacetimewithstuartgary.com, or from your favourite podcast download provider. Spacetime's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C., and available around the world on TuneIn Radio. If you want more Spacetime, check out our blog where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us on Twitter through @StuartGary, at Spacetime with Stuart Gary on Instagram, and on Facebook, just go to www.facebook.com/Spacetime with Stuart Gary. Spacetime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to Spacetime with Stuart Gary. This has been another quality podcast production from Bytes.com.